Okay, let's do a second example of taking the inverse of a matrix. We're going to take matrix B this time. We're going to do the inverse of this. Just remember, the examples we give, or I give, usually have nice pretty integer values. They don't have to be integer values. So if I'm taking the inverse of this, remember I'm going to make a matrix like this, 2, 1, 6, 3, 4, 0. And I'm going to put the identity matrix on this side. And then I'm going to use Gauss-Jordan method to make this side look like that side. So here's one I set up earlier. I'm going to call this A, B, C. And the first thing I want to do is I want to basically reduce this down so I've got zeros here. So usually the first thing I'll do is make a 0 there and a 0 there. I'll do this in 2 steps. So I'm going to take row B and I'm going to subtract 2 times row A. So in this case, because we're working down, I don't touch this one, 0, 1, 5, 100, that's not changing. B is though, I'm going 2 minus 1 is what, times 2 times that. So 2 times 2 minus 2 is 0. 1 minus 2 times 0 is 1. 6 minus 2 times 5 is going to be what? Negative 4. And then we do the same across on this side. So this is going to be 0 minus 2a is 2. 1 minus 0, 0. And I haven't touched this row. 0, 0, 1. Okay, the next step I'm going to do is I want to get rid of the 3. So I'm going to do a similar thing. I'm going to go C minus 3 times A, because 3 times 1. So again, I'm not touching the top row, so 105, that's not altered. 100. Second row I'm not touching. But that third row, I'm going 3 minus 3 times that. So 3 minus 3 is 0. 4 minus 3 times 0 is 4. 0 times minus 3 times 5 is negative 15. It's getting big and ugly. And again, we do the same thing. So 0 minus 3 times 1 is minus 3. 0 minus 0, 0, 1 minus 0 is 1. How we're doing it? Did I get that? Negative 15. Yeah, that's looking good. Okay, so the next thing I want to do is I want to get rid of this one here, because remember I want this to be 1, 0, 1, 0, 0, 1. So the easiest way to get rid of this is I'm going to have to get rid of that. There's a 1 up there, so I'm just going to go C minus 4 times B. So remember, this is A, B, C. So I'm not touching row A, I'm only playing around with row B and C. So 105, that doesn't change. 1, 0, 0. B doesn't change. 0, 1 minus 4, minus 2, 1, 0. But C is going to be that row times minus 4 times that row. So 0 minus 0, that's easy. 4 minus 4 times 1 is 0. Minus 15 minus 4 times 4. So that's negative 15 times minus negative 16 is positive 1. Score. So I've actually done 2 steps there. And then again here C is going to be 3 minus 8. Minus 8 is positive 5. So 3 plus 8. Yep. And again we go that minus that. So there's going to be negative 4. And C 1 minus 0. Okay, so we're cruising along. Okay, so now that I've got this as leading edges as ones, I want to get rid of these two. So this becomes the identity matrix. Remember the identity matrix, everything is zeros except 1, 1, 1. So what am I going to do here? If I add 4 times this row to this row, that becomes 4, and that cancels out that. So B is going to equal B plus 4 times C. Not touching row 1 for this time. So 100. B is equal to B plus 4C. So 0 plus 4 times 0 is 0. 1 plus 4 times 0 is 1. Minus 4 plus 4 times 1 is 0. Now comes the fun part. B minus 2. Let's get this right in my head. Minus 2 minus 4 times, plus 4 times C, which plus, isn't it? This is plus 4 times C. So minus 2 plus 20 is going to be positive 18. Again, it's B plus 4C. 1 plus negative 16 is going to be negative 15. 0 plus 4. Okay, and then this row doesn't change. 0, 0, 1. 5 minus 4, 1. Okay, so now we've just got to get rid of that. The easiest way to get rid of that is going to be A minus 5 times C. So 1 minus 5 times 0 is 1. 0 minus 5 times 0 is 0. 5 minus 5 times 1 is 0. Got to do the other side. 1 minus 5 times 5 is negative 24. Okay, so 0 minus 5 times minus 4 is positive 20. 0 minus 5 times 1 is negative 5. So 0, the other rows are unchanged. 18 minus 15, 4. 0, 0, 1, 5 minus 4, 1. Okay, so as you can see, this side's actually got quite a bit bigger. Some of the magnitude of some of those numbers has got bigger. The easiest way to check it is to see that you actually have got the inverse is you take the obverse. 105, 216, 340. Remember, one of the properties is if you take the obverse, you multiply it by the inverse, you end up with the identity matrix. So we multiply that by negative 24, 24, negative 5, 18, minus 15, 4, 5, negative 4, 1. Let's just do one or two of these. If we end up, so we go minus 24 plus 0 plus 5, so we end up with 1. If we do the next one, we end up with 20 minus 20 is equal to 0. 5 minus 5 is 0. 2, so 48, negative 48. 18 is 30. That's going to be 0. 20 minus 15 minus 24. Woo! Okay, let's get this right. That's 2 times 20 is 40. Minus 15 is 30. 40, 30. This should be right. So 40 minus 15 is, what's that, 25. Plus negative 24, that becomes 1. Negative 10 plus that becomes negative 6 plus 6 is 0. And again, so negative 72 plus 72 plus 0, that becomes 0. 60 minus 60 is 0. And then we have minus 15 plus 16 times 0. So if we multiply these two together, we get the identity matrix. So that is the inverse of that.